Okay, this is section 8.4. We're going to jump around a little bit because this is a section that's pretty easy to do with some software, and you can watch the videos and hopefully follow along. So it's called Plane Curves and Parametric Equations. Okay, so what we've been studying mostly in mathematics are what we call Cartesian functions, which have the equation y equals f of x, such as y equals x squared, y equals x cubed minus 3. But we can get what we call parametric equations or a parametric function if we let x and y both depend on a third variable, which we usually call t to represent time. Okay? For example, x could be some function of time and y could be some function of time. And the graph that you get, you vary t to come up with xy points, which will change over time, and then you plot that path by just plotting the x's and y's, as we'll see here in a second with some examples. Okay, so our first example, we're going to look at x equals sine of t and just y equals t. So what you would do first is just take a collection of t values, and because we have a sine function, I've chosen to go from negative pi to pi with some of our common values, and couldn't get to the symbol very easily, so pi here is pi, as in 3.14 or something. Okay, so you complete the tables. The y values are just t, so we'd get negative pi over 2, and so on. For the x of t's, we would calculate the sine values, like sine of negative pi is 0, and then so forth. I have those completed here in a table. And of course at pi over 4 you get the square root of 2 over 2. I've rounded that to 0.707, and at negative pi over 4 we get negative 0.707. So you simply take a set of t values, you plug them into x's equation and y's equation. Instead of just plugging them in for y, now we have to plug in and find x's and y's. But then you would ignore the t values, kind of block these out in your mind, and just plot the points: 0, negative pi, negative 1, negative pi over 2, and so on. Okay, and I have done that here. So there are just the points, as you can see, and if we fill them in with a smooth curve as we normally do, there we see what we've actually got here. Instead of y equals sine, we've got an x equals sine. So we get a sine curve turned on its side, and because we only went from negative pi to pi, we only get this portion of the sine curve. Okay, so let's see what we have next. Here is an animation. I may have to create a separate file for those. Let's see, I would have to... There, it kind of goes out of the screen a little bit, but you see, again, a parametric function, you can actually think of it, if you vary t over time, as being not just a graph, but a path. This thing travels from the time there, from negative pi to pi. It maps out the actual sine curve. So sometimes a parametric equation, you can explicitly state the domain, such as t is going to go from negative pi to pi, or t is going to run from a to b. If you do, then when you plug in a, we call that the initial point. F of a, g of a would be the initial point, and where you end up, f of b, g of b would be the terminal point. So you can think of a parametric function as being like some particle moving over a path over time. Okay, for another example, this is actually a very familiar curve. If you sketch the curve with parametric equations x equal cosine t, y equals sine t, and let t run from 0 to 2 pi, you should have an idea what that's going to look like. We've been looking at something where x is cosine, y is sine, and we go from 0 to 2 pi. So I've plotted and have a picture of that. I plotted some of the points for our common points. This is the unit circle. We start out, if you plug in 0, we get our point there at 1, 0. If you plug in pi over 2, you get the square root of 2, sorry, pi over 4, you get the square root of 2 over 2, square root of 2 over 2. Plug in pi over 2, or 90 degrees, we get our point 0, 1. And then we go on around the circle. When we get to 2 pi, we're back where we started. So there's a very familiar curve we've been looking at, which is the unit circle, which has the parametric equation x equals cosine t, y equals sine t, if we let t run from 0 to 2 pi. I have another example in the notes. If we change it, instead of being cosine t and sine t to being cosine of 2t and y equals sine 2t, and run from 0 to 2 pi, it turns out you still map out the unit circle, but you do it twice from 0 to 2 pi. Remember, you not only get a graph, you get a path over time. And here I made the table going from 0 to 2 pi by pi over 4s, and here's our original unit circle going around. Well, if you look at cosine 2t and sine 2t, you're doubling the time, so in only half of the time you go all the way around from 1, 0 back to 1, 0. When you plug in pi, you're actually at 2 pi because of the 2's. And then you make a second trip around the circle. Okay? Now if this works, if this fits in the screen, you can watch these two images actually map it out. So I'll let this run a few times. If you watch, this is the 1 unit circle from 0 to 2 pi being mapped out. Sorry, it's going to be off a little bit.